Hey friends, today begins a new unit, rational expressions and equations. Um, Now, I'm going to tell you right off the bat, for every math course I've ever taught, there's this unit that I call the crying unit. And it's kind of a unit where sometimes kids can feel a little overwhelmed by the stuff that they have to do. This is one of those units for 20-1. Okay, now I'm not saying that to scare you. I'm going to walk you through this and I'm going to be with you every step of the way. Okay, but I am saying that just to kind of prepare you that, think about the amount of work you're doing right now. Rational expressions is probably going to need just a little bit more work than what you have been doing for some of the other units, just to stay on top of things, okay? The rational unit, really what we do with rational expressions is we take polynomials and all of our rules around factoring, and we marry that together with adding, subtracting, multiplying, dividing fractions, okay? Everybody's two most favorite F words in math, factoring and fractions, come together, okay? So if factoring is not something that you're super strong with, that's something you want to kind of get a goal for, is go back, review factoring. You're going to notice as we go through some of these things that I'm not going to show you every step to decomposition for factoring anymore. I'm going to go straight to the answer, okay? And that's because now I'm under the assumption that you're okay to factor, and that however you do it, you're arriving at the same answer as me, whether you do cross product method or decomposition or inspection, that you're okay doing that. Okay, so don't stress out when you see me go straight to the answer and you'll be like, how did he do that? I'm leaving that to you to do it however you like, okay? All right, so what we want to tackle today is kind of two things. We want to look at simplifying rational expressions, and we want to have a conversation around something called non-permissible values. Now, if you've been following me in the order that I've been teaching this, I've already done radicals. And so we've already talked with radicals around restrictions. And actually, inside radicals, we talked about non-permissible values, this whole concept of when we have a fraction, the denominator can't be 0, okay? So we have to state the things that our variable is not allowed to be, because it would cause a 0 on the bottom of a fraction, okay? All right, so let's get started. We want to simplify the following rational numbers without your calculator. Well, 2/4, you're just thinking about reducing that, and you're going to tell me that that's 1.5. Pretty easy, right? 56/98. Now, you're going to want to turn to your calculator, and I've asked you not to. And what we want to do is we want to think of, now, I want to say right off the bat, you may not write it like I'm about to write it, but I'm about to write it in a way that's, I just want to give you a visual for what's going to happen as we continue with this note. As it gets messier, you're going to see the same visual. So I want to establish that visual now. So what I want to do is I want to think of factors of 56 and factors of 98, where one of those might be common. Okay, I know that 56 is 4 times 14, and I know that 98 is 7 times 14. Okay, so what I've done is I've broken up 56 into 14 times 4, and 98 into 14 times 7. And the point is, look at this, 14 divided by 14 is just 1. So that's going to leave me with 4/7, okay? 4/7. And so the simplified version of 56/98 is 4/7. Now, write down an equivalent fraction to each of the rational numbers above, which for me, they're just on the left here. How can we always create an equivalent rational number? Well, the easiest thing to do to create an equivalent rational number is to multiply both the numerator and the denominator by the same number, okay? So it doesn't really matter what I do, as long as I do the same thing to the top and the bottom at the same time. So 1/2, I change to 4/8. 1/2, 2/4, 4/8, those are all equivalent fractions. How did I get there? I multiplied the top and the bottom here by 4. Or I could have looked at the original and said I multiplied the top and the bottom by 2, okay? 4/7, I wrote as an equivalent 8/14. I multiplied the top and the bottom of 4/7 by 2, okay? So we can create equivalent rational numbers by multiplying the numerator and denominator by the same number, okay, by the same number. Okay, so a rational expression is the quotient, oh, sorry, let me take that ink off for you. A rational expression is the quotient of two polynomials. We are really talking about fractions with some variables. The same rules of fractions that we learned way back in grade 6 are still going to apply, okay? Now, I'm not saying that in a condescending way. I'm saying that to say, you know how to do a lot of this stuff. It's going to feel intimidating at first, but we're going to go right back. We're all going to go we're going to do this together so that we're all on the same page together. And it's all going to come back to you, okay? Don't worry. The fractions are just kind of more complicated. So for instance, I've given you 3 below here, 2x over x minus 3, x squared minus 16 all over x squared plus 4x plus 3. And you can see right away, like this orange guy that I've written here for you, like you totally want to factor the top and factor the bottom, right? I can just feel it exuding from you. Or 1 over x there in the red. Those are all examples of rational expressions, okay? So what's the only number we can't divide by? 0. We need to watch for this when working with rational expressions. We need to make certain that the variable in the denominator is not equal to 0, as this is when the function will be undefined. And we call these non-permissible values, or NPVs, okay? They're super, super, super important. So the first thing we want to do is just kind of work through some of these non-permissible values together, okay? Okay, so state the NPVs for each of the following. Now, again, it doesn't matter what the numerator is. The numerator can be 0, no problems there. It's just the bottom. Now, some of you may look at this and say, okay, well, we're just going to take 8x plus 16 and set it equal to 0, which is great. I want you to get into the thought pattern, though, of factoring that first, okay? And that'll be very apparent as we keep going with this note and with notes to come. So I want you to think about this as 8 times x plus 2, okay? I'm just factoring out that 8. So we have 7x over 8 times x plus 2. Well, now it's also a little easier to see the NPVs in factored form because it's the factor itself that can't be 0. Well, what value for x would create a 0 on that factor? It'd be -2. So we have to say that x can't be -2, okay? X can't be -2. Now, if you were ever unsure what that value would be, you would take the factor and you would say x plus 2 can't be 0, and then just solve for x, okay? So for this one, it's pretty easy. I just subtract -2 from, or sorry, subtract 2 from both sides, and that would leave me with -2, okay? All right, good. Let's try this one. So I've got 3 over x cubed times x minus 1. So what I want you to notice here is it's already factored for us. I've got one factor that's x cubed, and I've got another factor that's x minus 1. Neither of those can be 0, okay? So x cubed can't turn out to be 0. Well, what value for x would cause x cubed to be 0? That would be 0. So x can't be 0. Okay. Then with my x minus 1, what value for x would cause x minus 1 to become 0? That would be a 1. So there are 2 non-permissible values here. X can't be 0 and x can't be 1. Okay. Okay, good. Now we get a little bit more complicated. We're looking at x squared minus 25 all over x squared minus 10x plus 25. Again, the whole purpose of these guys is you're going to want to factor. This conversation right now is just around NPV, so I'm going to ignore the top. I'm just going to look at the bottom, and I am going to solve the bottom by factoring. I know that x squared minus 10x plus 25 can't be 0. So that's the statement I started with. And now I essentially want to solve for x there. So I'm looking for 2 numbers that multiply together to give me 25, add together to give me -10. I know that those 2 numbers are -5 and -5. Okay. And so that would be x minus 5 times x minus 5, which would be x minus 5 all squared. Okay. So it's the same factor. But it also tells me that my NPV is that x can't equal 5, because that's what would create a 0 on both of those factors. Okay, so my NPV for that guy is x can't equal 5. Okay, and then this one's kind of interesting. 2x squared plus 5y all over x minus y. We're still just talking about NPVs right now. So x minus y, that's the denominator, right? I don't care about 0 coming onto the numerator. I care about 0 coming onto the denominator. So the denominator can't be 0 because I can't divide by 0 because division of 0 is undefined. So x minus y can't be 0. And then I could just bring my y over and say x can't be y. So x and y can't be the same value, essentially, is what we're saying there. Okay. All right. So now what we're going to do is we're going to turn our attention to trying to simplify these things. Okay. So these are kind of the steps I want you to think about. Very first thing you always do, even in the next few notes, when we talk about multiplying and dividing and adding and subtracting, the very first thing you always do is factor as much as possible, okay? Then you're gonna state all the NPVs that you see, then essentially divide out any common factors and then leave your answer in factored form, okay? So I'm gonna walk you through this a couple of times. Make sure you're feeling good about it. Okay, so the first one is negative 21x over 35x to the 4. Now, the first thing we want to do is have that conversation around restrictions, NPVs, non-permissible values. Okay, you're going to hear all those phrases kind of come out in questions. X can't be 0 because x to the 4, if x was 0 there, I'd end up with 35 times 0, which is 0. Okay, so x can't be 0. That's the first thing you'd want to state. Okay, now I want to look at this, and essentially I just want to reduce it, right? 21 over 35, both of those are divisible by 7, so that would reduce to 3 over 5. Then x over x to the 4, that would essentially reduce to x to the 3 on the bottom. Okay, now if you're happy with x to the 3 on the bottom, awesome. If you want to think about it as division first and say, okay, well, when I divide powers of the same base, I subtract the exponents. So 1 minus 4 gives me negative 3, and then the x to the negative 3 gets flipped to the bottom to become x to the positive 3. It doesn't really matter how you look at it, as long as you can get that x to the 3 on the bottom. Okay, so I'm going to have a negative 3 over 5x to the 3. Negative 3 over 5x to the 3. Okay. All right, so x squared plus x minus 12 over 2x squared plus 7x minus 4. So the first thing you want to do is factor. I know I said this at the beginning, but I am going to go straight to factored form. If that bothers you, if you do a couple steps through decomposition or you do cross product method, please make sure you keep doing that and then just verify your answers with mine, okay? I'm looking for two numbers that multiply together to give me negative 12. Add together to give me 1. I know that that would be 4 and neg 3. Here, I'm looking for two numbers that multiply together to give me negative 8 and add together to give me 7. That would be 8 and negative 1. Okay, so I just have to remember that those aren't going to be my answers because of the 2 in front. So if I was to do this by inspection, which I'm going to do, I would go like this, and I would say, okay, I've got 2x and I've got x. Then I need to get a 8 and a negative 1. Well, my 8 is actually going to come from these two terms being multiplied together, so that's going to be plus 4. And then my negative 1 will come from these two terms being multiplied together, so that's going to have to be negative 1. Okay, so that leaves me, the factored form would be 2x minus 1 and x plus 4. Okay, now, again, if you like decomposition, go ahead, okay? Take those two numbers, break the 7 down, then you're going to factor the front 2, factor the back 2, pull out that greatest common factor, and you're going to get the exact same thing, okay? So here I am in factored form. the next step was to state my NPVs. So want to have a quick conversation around this guy because you may not see this guy right away in your head. If you can't see it right away in your head, set it equal to 0, right? Because that's what we don't want. We don't want that factor to equal 0. So 2x minus 1 can't be 0. I'm going to add 1 to both sides and then divide both sides by 2. That's going to give me x can't be 1/2. X can't be 1/2. Okay, and then for this guy, I'll have x can't be -4. I don't care about NPVs on the top. I'm totally okay with zeros on the top, right? That doesn't break any mathematical rules. When you're doing your NPVs, I would like you to get into the habit of going from smallest to largest when you're listing them, okay? Okay, then I can look at this and say, hey, x plus 4 divided by x plus 4 is 1, right? They divide each other out, essentially. X plus 4 divided by x plus 4 is just going to give me a 1. And so now I'm left with x minus 3 over 2x minus 1. Okay, so my simplified version is x minus 3 over 2x minus 1. Now, be careful. Lots of kids will say, oh, that means I don't need to have this -4 as an NPV anymore. Yes, you do. Okay, NPVs don't go away just because you simplify the question. The original question was this, and in there, -4 and 1/2 are no bueno because they will cause a 0 on the bottom. Okay. All right, good work. 2x minus 6 over 3 minus x. So first thing I want to do is take that top guy and factor out the 2. So that's going to give me 2x minus 3 over 3 minus x. The other thing I did was I factored out a -1. Now, you may be asking why I did that. Let me hide that for 1 second and let me just show you what I originally said. I said I'm going to have 2x minus 3 over 3 minus x. Here's what I want you to notice about these two factors here. They both have a 3 and an x, but they have opposite signs. So on the top, I have a positive x with a -3. On the bottom, I have a positive 3 with a -x. So if I factored out a -1 from the bottom, that's going to now give me a -3 and a positive x. And then those guys say the same thing, so I'd be able to divide them out. Okay, so that's what I've done in that first one I was showing you. I took out the 2 from the top and a -1 from the bottom. Then I can say, okay, my x minus 3s will divide out, and I'm left with 2 divided by -1, which is just -2. Okay, non-permissible values, don't forget about those though. X can't be 3. Okay, x can't be 3. And I'm left with -2. Awesome. Okay, 3x squared minus 8x plus 4 all over 6x squared minus 4x. So again, I'm going to go and factor. I know that I'm going to have 2 factors up here. I'm going to have a 3x and I'm going to have an x. I'm looking for 2 numbers that multiply together to give me 12 and add together to give me -8. I know that those numbers are -6 and -2. So my -6 is going to come from here. 3 times -2 then will give me -6. And then I need a +2. Okay. Nope, sorry, I need a -2. That was my bad. Let me just erase that because I needed a -6 and a -2, right? Okay, and then on the bottom, I'm going to end up taking out a, 2x, and I'd be left with 3x minus 2. Okay, so my factored form should look like this. 3x minus 2 times x minus 2 all over 2x times 3x minus 2. Next step is to state my NPVs. I've got 2 factors on the bottom. One is 2x. That guy tells me x can't be 0. The other guy is 3x minus 2. That tells me x can't be 2 over 3. Okay, so x can't be 0 and x can't be 2 over 3. Now I can look at who divides out. My 3x minus 2's will divide out, and I'd be left with x minus 2 all over 2x. Okay, x minus 2 all over 2x. And that would be the simplest form I can do. Okay? All right. Let's try this guy. So for this one, I'm not going to walk you through the factoring. I want you to do it by yourself, and I'm going to show you the final product. Okay, so pause me, get it all done, and then come back and we'll compare notes. Okay, so you should have ended up with 2 times x minus 2 times x minus 3 all over 3x minus 1 over or times x minus 3. Okay, so don't forget, always you want to take out a greatest common factor when you can. It makes your number smaller, it makes your life a little easier, and you have to do it anyway because you need to completely factor each of these. Okay, so we're going to talk about non-permissible values. For 3x minus 1, I can't have that become a 0 because that would be 0 times something, which would make the denominator 0. That guy can't be, x can't be 1/3. Again, if you're not sure, just go 3x minus 1 equals 0 and solve for x. Okay, and then for my x minus 3, I can't be, x can't be 3. Okay, so x can't be 1/3 or 3. And then I see that my x minus 3's will divide each other out, and I'll be left with 2 times x minus 2 all over 3x minus 1. Okay, 2 times x minus 2 all over 3x minus 1. Awesome. Okay, now this last guy, I've got negative x minus 4 over x squared minus 16. Now, you want to kind of be able to look at the bigger picture here and think through where you're about to go. You know that x squared minus 16 is going to factor into x plus 4, x minus 4. Or maybe you don't. That's okay. Let me warn you. Difference of squares is something that, for whatever reason, kids have a hard time seeing. So as soon as you have 2 terms on the bottom, I really want you to ask yourself, really train yourself to ask good questions. And the good question that you would want to ask is, hey, could that be a difference of squares? And it is. It's a perfect square minus perfect square. So I know it factors into x plus 4, x minus 4. Now on the top, I've got negative x, negative 4. It would be prudent for us to take out a negative 1 because that would leave us with x plus 4, and I could divide out my x plus 4s. Okay, so that's what I'm going to do. I'm going to take out the negative, and I've got x plus 4 on the top. On the bottom, I factored my difference of squares, and that's x plus 4, x minus 4. Now I want to state my NPVs. I know that x can't equal plus or minus 4. Okay. Then I want to think about what divides out. I've got an x plus 4 and an x plus 4 dividing out. Be very, very careful with this. There's still a 1 on top. Actually, it's a negative 1, right? But just because everything seems to disappear on the top doesn't mean the top disappears, because when you're dividing out to create a 1, right? So this would be a negative 1 over x minus 4. Negative 1 over x minus 4 would be your final simplified answer. Okay, great work, guys. You got this. Okay, so here's your homework. Take some time. Make sure you're really comfortable with factoring. The purpose of this particular lesson is to give you a chance to refresh your factoring skills, to give you a chance to really wrap your head around non-permissible values, and to give you a chance to wrap your head around simplifying these things. As we move forward, we're going to get deeper into fractions, because now we're going to be multiplying and dividing in our next lesson, and then adding and subtracting in the 2 lessons that follow that. Okay, so use this opportunity to get super comfortable on those first 3 items, the factoring, the NPVs, and the simplifying, before we throw in some fraction rules to go with it. As always, please connect with me if you have any questions. That's what I'm here for. And I love it when you guys ask questions. Okay, you guys will never bother me asking questions. So ask away. Have fun. And I will see you for multiplication and division very soon. Take care, guys.